Hello everyone, and welcome back to another video. Today I will be teaching stack. Because stack and queue, they're pretty good pair with each other, and a lot of the LeetCode problems will have like stacks and queues most of the time. So I just thought, hey, maybe I should just do stack since the concept is almost the same thing or pretty much the same thing, and then just move on to LeetCode afterward. So what is a stack? A stack is a linear data structure that follows the LIFO, which stands for last in, first out. Last in, first out. And in a way, it basically says that the last item you put in is going to be the first one you take out. Kind of like when you're stacking a plate or a book, right? When you decide to stack a book, whatever you place down, the first book, second book, third book, fourth book. The fourth book is the last one you place down, but if you want to like start taking them out, you'll take the top one first, you know? And so it's a little bit different from queue. Queue was first in, first out, FIFO, whereas the stack is last in, first out. Actually, I'll just keep this. Now, some of the core operations were just the standard operations for stacks. We have push. For X, you just add X to the top of the stack. There's pop. Pop just removes and returns the top element. And if the stack is empty, then it creates an error, right? So push and pop. So compared to queue, push would be in queue, and then pop would be DQ. And same with DQ, it's if the stack is empty or if the queue is empty, then it shows an error or exception. We have peek, which again, from what I remembered, I also wrote one about for the queue. Yeah, there's peek / front, and then for here it would be peek or top. Because looking at it, stacks is when you're stacking things on top of each other. Queue is when you're forming a line. So that's why I have it for top. And then obviously the other one would just be is empty. Now peek / top returns the top element without removing it. You just want to see what it is. Is empty is just going to return true if the stack has no element. And then now the desired time complexity for push and pop should be big O of 1. So basically stack is last in, first out. Queue is first in, first out. And then now I'll begin to do the coding part. All right, so let's do the coding for the stack. And then for here, same thing. We're gonna use the same node class. We just reuse the style basically, and we're gonna use stack. So it's gonna be very similar to queue. You know, I'll be writing it in a very similar way. So first, let's create my stack, and then that uses a node top pointer. So just first comment it stack using and then LIF. Okay, static class, call it my stack, private node top. So for this is like a pointer. It points to the top of the stack. And then let's create a boolean. Let's do the is empty one first, because that one's easy. If it is empty, we just return top as null. So the purpose of this one will check if stack is empty. Next, let's do public void, and we're going to do push. So we're going to push an integer. I'm going to have node new node equals new node data. And then let's do new node dot next equals top. So and then top equals new node. So okay. So this is basically where new node like should sit on basically like the quote unquote top of the previous nodes. And then for here, you just basically be like the new node points to the old top. And then for this one, move top to new node like that. And that's it. That's how you push it. So when you look at from like enqueue, it's kind of the same. But the thing with enqueue, it's like, you know, that's another case. Let's do, well, actually, wait, is it? Let me double check. Yeah. Now with the pop, we're gonna do it like this. We're gonna have the base case because, like I said, if you don't have this, it's gonna show you an error. But for this one, if it is empty, we're gonna throw in the new runtime exception. Just say stack is empty, cannot pop, like that. Now we're gonna have int value dot top data. This basically gets value to return. Afterward, top equals top dot next. This, we're gonna move top down to next node and then return value. And that's it. So once you pop the whichever one is on the top of the whichever one's on the top, we're gonna move the new top to top.next. So this is the new top will be top.next, whichever's below it. So that's pop. Give me a quick second. Let me double check something. Okay. All right, let's do the next one, which is peak. So public in this integer peak, because we're looking for an integer. Again, if it's empty, throw new runtime exception. Stack is empty, cannot peak. Or top, you know. But since I already mentioned top way too many times, then, you know, I'm giving a new name, which is peak. Then afterward, once the if is good, you want to return top.data. Let me do something real quick. Okay, and then now after peak, we shall work on the print. Yeah, this one's kind of optional, but I guess I want to make it because I want to see when it prints out the stacks, you know. So public void print stack. Again, if is empty, we're gonna print stack. Stack is empty. And then you return. Other than that, we just print out without the line, like that. Top, we're gonna write it like this. Node, we're gonna have a temporarily that's gonna point to top. And then while the temp is not equal to null, we're gonna print out all the temp.data plus, and then we're gonna draw an arrow key. So it's kind of similar to queue basically. And then temp equals temp.next. After all of that, you print out null or bottom, and that is it. Okay, so now just making sure, because when you do look at the enqueue, there is a case one if the queue is empty. we don't need the if is empty in push for stack because the same to line works for both empty and non-empty cases. Okay? So it, in a sense, it doesn't matter if you have it or not. Now, let's see. Okay, I don't need this anymore, so I'll be getting ready to write out the stuff. So my stack, oops, and we're just gonna call it stack, my stack. Yeah, we're just testing it out. So stack, and we're gonna push 10. Stack dot push 20. Stack dot push 30. And let's print it out. So what this should print out is we're gonna have the top arrow key 30, arrow key 20, arrow key 10, arrow key null bottom. So kind of see how like I'm putting 10 first, but 10 is on the very last before null, because I'm stacking them up. And then let's check out peak. So I'm not gonna write out the whole thing, so I'm just gonna write peak. This should print out 30 right here. Let's do pop. No need for, and this again, it'll pop out 30. And then so if we print out the stop like that, this now should be top 20, 10, and then null bottom. Again, if we pop out both again, so print out stack dot pop. Oop. Stack dot pop. This one now should be 20. It's gonna pop out 20 and then pop out 10. And let's check if it's empty. Stack is empty, and it should print out true. So if we run this, perfect. So there it is. 30, 30, top 20, 20, 10, true. And that's it, basically. So in a way, it's very simple. If you've seen the Q video, it is pretty much like that, except just remember Q is first in, first out. Stack is last in, first out. So LIFO, Q is FIFO. All right, thanks for watching.